Good morning, everyone. Our topic today is white box testing. The name comes from the idea that the program that we test is available. We can read it, analyze it, so in a way it's kind of white box. The test itself consists of input and output. This is the usual definition of the test. But here the input is based upon analyzing the program, and the output is still based upon the task or specification. Think a little bit of why we cannot base the output on the program. What is wrong in this case? So we need to base the output upon the task or specification. If we think about what additional we have when we have the program text that can be used for testing, for creating tests, then obviously the code can be used in a variety of ways. One way is that we want to cover different parts of the program or its components, so cover its tests. We analyze shortlist statement, branch, path coverage. We compare criteria. We can also use different other ways of white box testing, such as data flow testing based on definition and usage of variables and so on. We could use static methods such as reviews and formal methods included on the testing in some testing frameworks. But today our topic in this video is coverage tests and criteria comparison. The first obvious criterion for white box testing is statement coverage. So we want to be sure that as a result of testing, every statement in a program has been working at least once, or we can state that, say, 80% of statements must have been working at least once or something like that. And we deal with the questions: is it possible to fulfill? Is it enough? How many tests are needed for testing program statement coverage? As a first very simple example, let's have a look at this function which computes maximum of given two inputs. How many tests are needed to cover every statement? After thinking about a little bit, we may realize that actually one test is sufficient, because let's take as an example test with input a equals 3, b equals 4. We read, we compute maximum equals 3. Now b is more. We execute sentence 5. Maximum becomes 4. And this function finishes. So this one test, which includes input 3, 4 and output 4, is sufficient for statement coverage. How many tests are needed to test this function by statement coverage criterion? Again, we could analyze how many different possible statements are here, how many statements can be executed during a single test and arrive at the conclusion that we need at least 1, 2, 3, 4, 5, 6 tests to test this fragment by a statement coverage criterion. What about this text? Is it possible to fulfill 100% statement coverage requirement on this fragment? Obviously not. And this is the case for many other possible reasons. So statement coverage is not always possible to achieve. Full statement coverage is not always possible to achieve. So, as a summary for the statement coverage criterion, the concept of this criterion is that all parts of a program have been working, or some percent of parts of statements have been working. There are some obvious preconditions. The program text should be available. It should be possible to analyze the text. We should have time, skills, tools, and perhaps other resources for this analysis. Advantages of statement coverage criterion. The program has been systematically tested. For example, for some added statements which do not show up during black box or functional testing, statement coverage criterion attempts to cover all these parts. Statement coverage gives few tests, as we saw. The concept is very clear. It's easy to explain it. Also, nothing is ideal, so statement coverage has its disadvantages. The coverage is not very strong. It doesn't give data tests. If there are empty branches, the statement coverage does not cover them. So the branch coverage is the next one. We will see the program text is not always available, and statement coverage, as we saw, is not always achievable. Result of a statement coverage criterion is a test set which covers all statements in the program, so systematically covers the program text. It should be used together with other methods and should be used when white box testing is needed, but time is scarce, so it's easier to use than the other methods. And there are many tools which help to design tests or which help to evaluate statement coverage. Our next criterion is branch coverage. So it says that all transitions from each statement to other statement must be covered. To analyze branch coverage, we need to understand how the transitions from the statements to other statements work. So the program execution graph is helpful here. For the same program we had before, here we have the execution graph. We join statements 1, 2, 3 into the first node of the graph. The next node is number 4, and from node 4, statement 4, we can proceed either to statement 5 if this condition is fulfilled, or statement 6 if it's not fulfilled. Based on this graph, we can see that now we need at least 2 tests to achieve branch coverage versus 1 test to achieve statement coverage, because we need to cover both this branch, which follows from 4 to 5 to 6, and this branch, which follows directly from 4 to 6. I leave to you to think about what is a branch coverage test suit for this example. Just keeping in mind that it needs to cover these branches, both branches, and it needs to include at least 2 tests. Here is another example we had before we understood that we need 6 tests for statement coverage. What is missing for branch coverage? Again, I leave it to you to design a branch coverage test set, and we proceed to multiple condition coverage, which is part of a or maybe considered a subset of branch coverage. In this method or coverage criteria, we take advantage of noticing that a single condition, if it includes multiple subconditions, may be considered as a multiple branch program. So here we have a single condition which consists of several subconditions, and we denote by A this first PIH more than 20, by B the second pH less than 25, and C PI education is high. We could use it as a single condition, so we could use here a similar graph as was in the previous slide. But if we use or detail it into subconditions, we see that from this first inequality PIH more than 20, we can proceed either to the second, so this A is this one, B is this one, and C is this one. So from A, if this A is not fulfilled, this first part is not fulfilled, there is no sense to compute B, so we directly go to C and compute if PI education equals high. So this is this branch. Or if we get this A right, then we need to compute B because this is an AND logical connection. So, and if this AND is fulfilled, then we from B directly proceed to 6. If AND is not fulfilled, we proceed to C, and if the C is fulfilled, then we proceed again to 6. If not, then we omit this print sentence and go to 7. So here we have already a more complicated program graph, and we can see how many tests are needed to cover this program graph. Now again using the branch coverage criterion. So we want to cover this task by branch coverage criterion. Looking on this graph, we can notice that we need one test that proceeds directly through all these statements. We need another case which covers this one. Now, perhaps it's not always possible, but perhaps we can join these two cases, but we need to cover this branch and this branch. And finally, we need to cover this branch. So looking at this, and obviously if we have several records in this file, we cover the returning back branches and the exit branch. So we need at least 3, perhaps 4 tests in a test set that would cover that would satisfy the multiple condition coverage criterion. The final coverage criterion we consider is path coverage, which states that all paths in a program graph should be executed. So we should understand what is a path in the program graph. A path is a sequence of nodes in the graph that starts from the start node and finishes from the exit node. So, for example, a path may start from 1, 2, 3 and then directly proceed to 9. Please think about when this path can be executed. Another option is that the path starts from here, from 3, then it goes further to 4, 5, it goes to 6, 7, 8, returns back and goes to 9. Again, think which input may result in such a path. Or a path may start here, 1, 2, 3, 4, 5, omitting 6, 7, 8, returning back. Or a path might start here, going to 8, returning back. Again, second time going through this. Then perhaps third time going through this branch that omits statement 6. Again back. Again here, again omitting and so on, and finally going to the exit or end function. So let's think about how many tests are needed if for this program there is maximum 1000 records in this file price. Obviously, we could have an empty file and go from here to directly to end. We could have one record and go either in this way or in this way, and to the end. We could have 2 records, and if we want to cover all these paths, we need to cover all the combinations of possible sequences of the nodes, so resulting in a huge number of tests. The ranges or something like 2 in degree of 1000, which is unreachable and unimaginable number in any respect. So path coverage if we have iteration and the condition inside this iteration is mostly unrealistic. But for other cases, path coverage may be useful. Please think about how many paths are through this fragment. So this is the same fragment but without iteration now. How many possible paths are needed to execute through this fragment to have path coverage. If we compare these criteria, we see that the statement coverage is the weakest. The least number of tests are needed to satisfy statement coverage. The branch coverage is stronger and the path coverage is the strongest. But for many cases, path coverage is unrealistic, so branch coverage is suggested in most times. So we want to cover all transitions, and please think about why branch coverage is stronger. Is it possible to cover all transitions and not cover all statements? Now, one more small quiz. Suppose we have a program, what can be done? Could we answer this question? Could you say, having a program, could you say how many tests are needed to test this program? Or having a program, could you say how many tests are needed to test this program by branch coverage? Or could you say, what are the branch coverage tests? So the key points to know from this small discussion are: first, what is white box testing? It's testing based on analysis of the internal structure of the component program system. We have different kinds of code coverage: function, statement, branch, path coverage. We didn't consider function coverage, but it's obvious we have many functions that then the function coverage says that we should execute at least all functions in this system. We didn't consider in this video data coverage and loops, but please have a look at this course website and additional materials. And if we compare white box to black box, then of course there are many differences. The first difference is the method and the idea, and these methods give different results. White box testing allows to find out problems which do not manifest in black box testing, and vice versa. There is a lot of literature available on white box testing, and the main materials are available on Moodle and on Tepandi.ee. So thank you for listening and have a good time.